Welcome to another Fortress industry-focused machinery safety webinar. Today we're going to have a look at safe access to machinery in the food and beverage industries, including some of the hygienic requirements that are not often covered in some of these webinars. We're going to keep it brief and to the point, be about 35-40 minutes, and we're even going to attempt to entertain as we continue in our bid to be marginally better than the bold and the beautiful. Your presenters today will be Rob Stark, President of Fortress USA, and Eve Edwards, our US Standards Specialist. I'll be your host, and my name is Malcolm Sharp. Please use the Q&A function, which is at the bottom of your screen if you want to ask any questions. If you want to chat with the panelists, please use the chat function. So remember, questions in the Q&A function, chat in the chat function. We'll have some prizes to give away, and hopefully we'll have a question at the end of the quiz. We'll tell you all about the prizes a little bit later. But as ever, every expense is being spared at Fortress, so don't hold your breath. Enough from me, and I'll hand over to Rob.
So thank you very much, Malcolm. Hopefully you can all hear me. Yeah, today's very much will be probably a little bit under the time slot that we had set aside, and we'll be really looking at some simple retrofit solutions for machine safety, talking about why it's important from a standards point of view, so mixing in a bit of useful knowledge along the way. It's worthwhile being said as well that we're doing this alongside of our channel partners based in the United States, Powermation. So most of you will probably be around from the central states, but we have done this type of information previously, but there's some more important stuff in today's presentation that no one will have seen before, so worth looking out for. In terms of content, what we'll be looking at today, that reading list of standards to give you a bit more info of what you might be able to take away, and we'll be drilling into some useful snippets to consider regarding machine access and similar. We'll then start looking at some of the retrofit solutions, looking at some safety devices designed for washdown, and then talk around maybe some of those applications which aren't actually safety related, but are really useful to use technology for in this type of food and beverage type industry. Joining me on some of the standards, insights and similar will be Eve Edwards today, looking at machinery safety. So Eve is actually our US standards specialist for machine safety. She is available, and please do put any questions in the question and answer function today. Eve, do you want to introduce yourself and then just start talking around what we'll be looking at today in terms of some standards?
Yeah, absolutely. I'm sure you can tell from my accent that I am the US machinery safety specialist at Fortress. I do spend a lot of my time looking at US standards as well as the international standards. So if you've got any questions kind of on either of those, I'm happy to try and help. In this presentation, we're going to be looking at some generic machinery safety standards. So that's mostly going to be B1119 and B1126 as far as the US standards are concerned. And we'll also be touching on hygienic design standards as well, of which there's kind of quite a few different ones, both in the US and across the rest of the world. But we'll kind of mention them. I'm not expecting you to remember any of this now. We'll pick them up as we get to them as we go along.
Perfect, thanks Eve. And the other thing we'll touch on as well when it comes to hygienic design, we will make a reference to the fact that the 3A Sanitary Standards Institute exists for those making a lot of equipment in America. And then for those that have made equipment for Europe previously, there is European Hygienic Design Group as well, which is the EHEDG group. Before moving on, a bit of an intro to who we are. So we are actually from Fortress Interlocks, which is a UK company, but our manufacturing in America is based out of Kentucky. So we're just by the Ohio border, actually just outside Cincinnati. We're global in terms of the way that what we product supply and who we supply to. And a lot of the product that we supply looks like that image on the left, that red and black stuff in the middle, or that silver stuff with buttons, but also our mechanical trapped key product range that we tend to be known for in this type of industry is shown on the right. That's actually a hose that's interlocked in place at a dairy facility. And I think that hose they get changed in and out. You can see there's a yellow lock on the right, there's some blue locks on the left of that image. They get changed out for different parts of the cleaning process. So they connect up the hoses, ensure that they're connected in and locked in, and then they go on and turn on the high pressure types of the cleaning process. We're really interested in controlling processes and ensuring things are done in a safe way, any application to do with safety of people or safety of equipment tends to be what we're interested in. On that note, we're going to talk through a little bit of some applications. And one of the applications we want to talk to is what is a simple solution suitable for washdown areas. Washdown areas for us, we tend to say, well, going to need to be water resistant, going to need to be corrosive resistant as well, because that washdown is likely to have a caustic type solution. In terms of the stuff that's directly to the process, this is where mechanical type interlocking can become really, really interesting, because we can remove a lot of the complex electrical components from the machine mounted part of the system. And what we mean by trap key technology, or what we mean by this type of stuff, is that we can mount the switch in a panel that is outside the area. We can supply an IP rated panel switch as well, which might be IP67 rated, so it's going to resist water. But we mount that switch in a panel outside of the direct washdown area, and then we use a key to transfer between that lock that directly drives the safety switches. We can isolate two normally closed contacts in the safety circuit, and then we use that key to transfer across to an access point where we unlock that door. And the key thing to remember about trap key technology, key being a bit of a pun there, is that with trap key technology, the key is trapped when the door is open. So at any point when that guard is open, that key is mechanically stuck in that lock. You cannot remove it, and you cannot take it back to the switch until you close the door again, insert the actuator back into the mechanical trap key device. That then releases the key. You can reverse the process, go back to the key switch mounted in the control panel, and start things back up again. Hopefully that makes sense. I know some of you will have seen that type of technology before. This is more of an introduction to say, if you haven't seen trap key, that's what it's all about. Nice and simple to remember: a switch, a door lock, and the key that does the transfer in between. It means that you made some nice savings of not having to put any electrical wiring to the access point. There is a few things to consider. One of the things to consider is all around, what if it is whole body access? Image on the right here is a mechanical door lock from Fortress mounted in the middle on a bottling machine. I believe this is from one of the large soda manufacturers in Europe, this particular picture, because I think there's some European text on there. But as you can see, it's a fairly big area and a fairly big machine. And if you were to open that guard, you would walk inside that machine, and you maybe end up hidden underneath it performing a maintenance activity, or you'd be out of sight from the person that's closing the door again. And we call that whole body access. Whole body access is something interesting. It is defined in safety standards. So at that point, it's a nice link back to Eve to explain a little bit on the definitions of whole body access.
Yeah, absolutely. So whole body access is defined in B1119 as a situation when an individual can be completely inside the risk reduction measures defining a perimeter or safeguarded space. What that basically means is if you can get inside the guarding, then it's whole body access. And there's lots of definitions on what gaps that means. I think it's 7-inch slot or 9-inch circle or something like that. But that's all in the standards. But then in terms of what you should do about that is probably more interesting. So the first thing that you should do, and it's worth noting, if you can see the people really clearly, then sometimes it may not be required to have additional things. If that's deemed sufficient, the person resetting the machine can definitely, absolutely know that no one's in there. If you can't do that, then you might want to use presence detection. So you could use laser scanners, or as pictured in there, that little blue thing is actually radar. So anything to be able to tell if someone is in there when they shouldn't be, to stop you being able to reset the machine. Other things, a really good concept that they have in B1119 is inhibit functions. So that's functions which are going to stop you being able to restart the machine when there's someone inside. So a proactive inhibit function is giving that personal control, that's giving the person going inside the peace of mind to know that they've done something to make sure that that can't be reset while they're inside. And that's things like safety keys, that can be interlock blocking and different things like that. I think Rob's going to talk about safety keys in a second. And if you think that even proactive inhibit functions aren't going to be sufficient, then that's where you can use reactive inhibit functions as well. And that's going to be things like escape release. So they're kind of for oh dear, I've got stuck inside, the machine's about to be reset, what do I do now? And giving you a means of stopping the machine and getting out.
Yeah, so that bit's really interesting, that definition or that difference between proactive and reactive. As Eve mentioned, we'll demonstrate a little bit of how you just adapt the technology for a proactive inhibit function of that we call a safety key, because it's a key that can, in theory, keep the operator or the employee entering inside the safeguarded space safe. What that means is, in terms of Fortress product, is that you can still have that switch mounted in the panel further outside the area, maybe not directly in the washdown. You can still have a mechanical device mounted on the side of the machine in that type of environment. But importantly, it's now changed from having a single key and a single lock to having two locks with two keys. The way those keys interact are one key in, one key out. So as you take that key from the switch, walk it over to the machine, insert it, trap it in the lock, you then have the ability to release that upper key. That upper key is the safety key that the employee retains during access. If they've got it around their neck or in their pocket, no one will be able to close the door behind them. No one will be able to start the machine, and they will be safe while they complete all of that activity. Again, hopefully that makes sense. This is sort of the basics of some of the trap key, that technology you may or may not be familiar with, but overall it's not too complex. It really is a nice, simple, efficient way of retrofitting. At this point, we're going to mix in something that we've never really talked about before publicly, because it's a bit of an interesting application. It's a bit niche. It doesn't come up very often. It's not related to safety, but it is reusing some of the technology that we've just been speaking about. The application that we'll demonstrate here is actually from a meat smoker application we've done in Canada opposed to in North America. And at this point, we weren't interested in safety of people. We weren't interested in locking doors closed, stopping access. The customer here was only interested in restricting access to the distribution of smoke in a meat smoking application. So I believe they were manufacturing sausages. It doesn't have to be sausages, but they would have sausages flavored in different types of smoke, and the way that they would control this smoke flowing from a room or populating a room would be through the use of a simple isolation valve. But the trouble that we were having was that occasionally people would make mistakes and they would mix the wrong batch, or they would flavor the wrong batch, the wrong flavor. And when that ended up in stores, that caused large problems. People opened a packet that they thought was maybe maple smoked bacon or maple smoked sausage, and it ended up being hickory smoked. So what they actually started to do, they started to implement trap key devices to control the process of what could you do and what could you do in different order. The basics of what they were looking to do was, if this one was isolated, they could open the other one. If that one was isolated, they could open the first one, but they couldn't definitely operate things out of sequence. They couldn't ever mix two things together. And the way that they did that was that they ended up setting up different locks colored in different colors, and then different keys colored in different colors. And then in that relationship, they would have two locks, but one key, and that instantly sets up a relationship where you can only ever operate one of those devices at once, because you've only got one key that can ever turn that lock. The units themselves were actually bolt modules, so that bit at the top retracts in or extends out. So what they should actually do in this application was that they would maybe isolate two forms of smoke distribution by locking those valves in the closed position. That would then allow them to extract those yellow and that red key on the right of the image, take it across to maybe the one that they want to open. And when they open it, in order to open it, they needed to insert the keys. That would trap the keys in the device, and then it would retract that bolt down from the top of the unit out of the little notch in the valve, and then allow the valve to be turned and the next bit of smoke to be opened. It really speaks a little bit back to some of Malcolm's favourite stuff on the history of trap key being in electrical power and controlling a sequence of operations for electrical power. This is actually just now controlling a sequence of operation for smoke distribution in meat production. Not necessarily anything we'd ever think about for Fortress, but something the customer was really pleased with, because it was a simple, nice and easy to understand solution that stopped them having any problems. Hopefully that makes sense. If that confused anyone a little bit too much, feel free to ask some questions. We can arrange for to do a follow-up and explain some of those type of applications and capabilities as well. On that, if we haven't completely put you off talking about mechanical technology, we are going to move into the dizzy world of some more electrical and electromechanical technology. So it's important to know that Fortress doesn't just do mechanical technology with keys. We do electromechanical technology, and we do it focused on niche applications and niche environments. One of our key vertical markets is the food and beverage industry. On electromechanical products, we design and we provide full stainless steel construction safety switches. So maybe you've seen safety switches in the market, but you won't have seen ones that are made quite like Fortress. We tend to focus on being nice and robust, suitable for cleaning, and basically trying to be the people out there that people turn to when they need something which is high misalignment, small, stainless steel, and market leading in its robustness. A few things to consider here though, because on the slide you're looking at a stainless steel non-contact sensor from Fortress and also a stainless steel guard locking interlock from Fortress. They need to be considered for their applications and they need to be selected correctly. The thing that really derives whether you would be able to choose one, not the other, is something called rundown times. And it's time now to pitch back over to Eve to talk a little bit about rundown times.
Yeah, absolutely. So there's a really handy little flowchart in, I believe this is in both B1119 in some respect and in ISO 14119 as well. And basically, if the overall stopping performance is greater than the access time, then you need guard locking. And what that means is if it takes longer for the machine to become safe from when you shut it down to if that time is longer than the time it takes you to reach the place that is dangerous, then you need to have something that holds the door shut while it completes that rundown cycle. And that could either be because you don't want the machine to turn off in a certain part of the cycle because it's going to ruin the product or it's going to cause damage to the machine, or in a safety perspective, it's going to be because you've got maybe a mixer that's going to carry on moving and it remains dangerous for some time, even after the power's been taken off, or it could be, you know, a big rotary saw or anything like that. So basically, if it takes longer for it to become safe than it does for you to get there, then you need some form of guard locking, which holds the door locked until it's safe.
So hopefully that all makes sense. Yeah, for me, completely easy to understand is that if the machine doesn't stop, you need to keep it locked closed, and importantly, you don't change your safety circuits. You don't change your safety state until that machine has then been confirmed as stopped. A couple of different ways to do this, but the application that we're going to talk through is typical type food mixer application where you'll have a spinning, rotating object inside the food mixer that has an inertia. If you were to kill power to that unit, it would still spin for a certain amount of time because it's got a certain amount of inertia keeping it spinning and rotating. But in this case, in this type of application, it's not a uncontrolled stop, it's a controlled stop where the operator has walked up to the control panel, requested the machine stop via a button, request to enter button, doesn't have to be a button, could be via the HMI, could be via another means. And basically in this arrangement, you have an interlock mounted onto the mixer access hatch, and that interlock is solenoid controlled, so that remains locked until the PLC determines, or the safety related parts of the control system determine that mixer has come to a full stop. That could be via maybe a zero speed detection, it could be via a timer, it could be via a couple of different ways, but if you imagine it's just via some type of logic control. Gets to the end of that process, after that rundown time that Eve mentioned has elapsed, it then signals to unlock. The little coloured LED at the bottom of the unit changes colour, and then it allows that hatch to be opened and opened all the way up. At that point, when you're opening up that hatch with this unit itself, you're actually breaking an RFID contact and a mechanical contact, and that machine cannot be restarted until that hatch is closed back again and that unit is relocked and said it's safe to run because it's in a closed and locked position. Sometimes we'll mention closed and locked, and we'll refer to it as safety on guard locking. This type of relationship where you've got a rundown time, you will want to have your safety state change upon guard locking or guard unlocking. Hopefully that makes sense. The next bit, standard snippet we'll talk about, moves away a little bit from machinery safety standards and actually starts to talk about hygiene requirements. So there's some really nice European standards out there. for hygiene requirements. One of them is referenced on the slide, EM1672. You often see that image on the right being the thing that gets to be communicated and gets to be seen at other places. That's image on the right all determines areas of equipment. And in terms of, if we just run through that slide, you'll look at areas that are labeled A inside the food mixer on the internal walls, and then also at the bottom of the mixer, get labeled as a food area. And one of the reasons they get labeled as a food area is that if any material was to splash up on it, it would run back down into the main mix of food. You can see those little blobs on the side of the container are running back down the sides into the food at the bottom. If we then look at area B is actually the food product itself. It's the actual thing that's being mixed, whether that's liquid or whether that's some other type of food mixture. That's the food product itself. The more interesting areas for us to interact with is what we get, or what people refer to as a splash area or a non-food area. So a non-food area is pretty much does what it says on the tin. It's the outsides of the vessel where food won't come in contact with. And if any food was to fall on it, it wouldn't run back into the product. It would just sort of drip on the floor. A splash area is then the bit that to concentrate on, because that's not something everyone ever, or it's typically the thing that people might consider last. A splash area is where food might splash up to, food product might get to that point, but importantly, it will drain away from the main food product mixture itself, and it'll end up dripping on the floor. So what that means for us, our devices tend to operate in a device which is a splash area opposed to a food product area. That's where our devices tend to get linked back into safety standards, that we tend to be mounted on the outside of the vessel, or we design our devices in a way that if any material was to land on them, it would run off, run away, and drip onto the floor, opposed to be dripping back into the food mixture. That's the basics of hygienic design that we consider when it starts looking at interlocking devices. However, it's not all just about Europeans. There is the ANSI 3A documentation as well that's available. Those repeat some of the points on the previous slide, but do it less in pictures, do it more in some of the text on there. If we just pull out some of the bullet points that are on there, is that the 3A, basically community, ensure that equipment is designed and fabricated to be cleanable, i.e. anywhere that material touches should be touched by water or touched by caustic solution when it gets mixed. Product or manufactured items should reduce the number of cracks and crevices where product residues may lurk. This tends to relate to metal joins. Anytime you've got two flat bits of metal joining up together, you will get a very, very small crevice where food can sit and things can join. For anyone in the industry, that's sort of telling you to suck eggs. But what it means for our devices, you'll tend to see them mounted off on those big standoffs you see in the right-hand image. So they're not mounted up against a flat plate. And then you'll also see those blue bits of gasket mounted between metal and metal surfaces to ensure that if any time there is a risk of metal to metal touching, they're actually isolated by that gasket in between them. Last couple of points, then start talking about materials, about using materials that facilitate the removal of soils, smooth surfaces, but also in the design of it, radiuses, curved edges. You can see there's an angled top to that unit in the device. You can see that there's sort of angled in the middle as well. So anytime something was to run onto it, it would have the ability to run away and drip off. Other thing around it as well, manufactured from stainless steel, tends to be a compatible material for the aggressiveness of cleaning and sanitizing chemicals. Last one on there, I think really links to the start, so won't dwell too much on it, but yeah, ensure every surface that can be touched by a product will also be in contact with cleaning solutions. Try and make things as open as possible. This is where it becomes really interesting for us, because we've used RFID in that product on the right to make that actuator type locking mechanism really simple and really open to make it as cleanable as possible. This is a product which is new for Fortress, and it is something that feel free to get in contact for more information about. It's a product that we call the hygienic guard locking device, because we believe it to be really the only offering out in the market which is designed to basically incorporate as many features as possible, if not all the features from hygienic design standards in a safety product. We're not taking a safety product and adapting it to food and beverage type equipment. We're not adapting it to a hygienic application. We're designing it from the ground up to suit these type of applications. So it's manufactured from 316 stainless steel. It's as open in design as possible. It uses that RFID link to really simplify the design. It's got stainless steel connectors. It's got the LED at the bottom that's all exposed, nice and cleanable. And basically, it can also be mounted on those nice little standoffs as well with bits of gasket. Incorporates the blue lines and the blue gasket everywhere to make it nice and easy. Sort of takes us towards the end. The back end of the presentation will be a return back to some mechanical product and share some information with you. And this is now talking about some niche applications that we see coming up in this industry more and more. And maybe it will offer the ability to solve a problem that you haven't necessarily considered before and make all these systems sit nicely together. We're going to actually now talk about alternative power sources, and we're going to talk about pneumatics. But before we talk about pneumatic control, we're going to just review what safety standards should be applied for pneumatic control, which I think is going to be Eve jumping back in again.
Yeah, just very quickly to kind of make the point, people don't often think of functional safety as including pneumatics and hydraulics and things. They think of it purely as electrical, but both 13849 and B1126, whichever one you're using, specifically says that they do include pneumatic, hydraulic and mechanical components and energy sources. So you can use your performance levels that you might already be used to describe pneumatic systems, even if they're not electrical, or if they've also got electrical parts to them as well.
Cool. Hopefully that wraps up. But yeah, makes life easy as a sort of a controls engineer, because it means that you start to apply some of the similar standards. And for our side, we actually start to apply some of the similar product. If you remember back at the start, we were talking around isolating electrical power in a key switch and a control panel, and then using that key to transfer to a mechanical door lock to open the door. In this case, we're actually isolating pneumatic power in the panel through a pneumatic switch, and then taking that key to the door and then using that key at the door to not only unlock the door and open that actuator at the top, but we're also using it to switch a safety switch mounted beneath it as well, which actually gives now electrical monitoring at the door back to the safety related parts of the control system. But that electrical monitoring by use of the key also confirms that the pneumatics have been isolated as well. In terms of where this tends to get used, it tends to get used in the distillery industry, and we don't really know whether it's speaking to the fact of this is a great product for the distillery industry, or Fortress just really likes to spend a lot of time in breweries. Who really knows? We're not really going to hold anyone accountable there. We know why that people might be making sales calls to distilleries. Tends to be some product thrown away at the end and ends up in the boot of cars, or the trunk of cars, as you might say. But in all seriousness, this tends to be a retrofittable solution to all equipment, and it does tend to be favoured for things like heating tanks in malt distilling sites. Anywhere access is required, and operators are required to isolate the air supply for access that they then achieve through maybe a hatch door or similar. They can get a little bit more complex in this simple type arrangement as well. So in large breweries where optimal utilisation of the equipment is usually necessary, there's basically usually one large vessel for mashing. For the processes that happen amongst that, there's usually a couple of different parts of the system you're interested in. Usually interested in the stirring mechanism, which is a bit of a mash rake at the bottom, turning everything around. Then you're looking at your heating methods. So basically using pumping steam through the malt to heat it all up. And then alongside all of these as well, everything tends to be made of stainless steel, nice and easy to clean. And what we end up with is these large type systems where they might have multiple different parts of control going on. They might have air supplies, they might have steam supplies for different parts of the process. And then they'll also have electrical supplies for the steering mechanisms as well. And we tend to see trap key being used to draw all these different parts of the equipment together in one simple retrofittable solution, which enforces a process before access is possible. If you haven't managed to decipher the schematic that's on the screen, the thing that we'll show on the next slide breaks it down into what's actually happening there. So in that slide, you've got a pneumatic switch, which is isolating the pneumatic power. You've then got 3 different types of electrical power in that system. So you can see on there on the left of that slide, you've got a pneumatic key switch. You've then got 3 electrical key switches. Those all have a key associated with them that's unique. Those keys then get removed, taken to a solenoid controlled key exchange, which is that device in the middle where you'll see the 4 keys trapped at the top, the 1 key out at the bottom, and then that object at the bottom, which is now a solenoid unit for controlling the release of those keys. The reason there's a solenoid unit there to release those keys, opposed to it just being a purely mechanical key release situation, is that there's a rundown time associated with isolating that pneumatic power and that electrical power. So speaking back to what we covered on rundown times, in this case, you actually have a rundown time associated. After that power is isolated, the control system waits until it unlocks that solenoid, then releases the key that can be taken back to the mechanical door lock. These systems can be extended for multiple door locks and all these other type of things. As well, hopefully get the concept of having to provide a wire and gate solution. You can provide a mechanical only solution, which allows you to retrofit it to the machines nice and easily. That's taken us over the 30-minute mark. We did promise that we'd be under time for the sort of 45 minutes that we booked out. Gives us the opportunity to answer some questions, but please stay on because we'll look through the all-important prizes and the poll of stuff we can give away. So in terms of, just to wrap up, what did we cover? I believe we covered a reading list of relevant standards. I believe we looked at some standard snippets to consider. I think from the applications, we went through washdown designed equipment. We went through retrofittable solutions. We also looked at the electromechanical stuff. We did a bit of an interlude into the meat smoking application, showing it doesn't always have to be safety applications. We then looked a little bit at pneumatics and the types of distilleries. The things that we'll share with you, just one more thing, is something new we've done as well for this industry. This is something which is currently unlisted on YouTube. It will be coming out, I believe, on the Fortress LinkedIn page on Friday. This is actually a virtual reality environment we developed for a large cereal producer, where they've got these drum dryers in their facility that's used to dry cereals and process cereals. In this application, they're actually using a lot of mechanical trap key interlocks. You could see on the right on the guarding. So I think in total, they've got maybe three on one side, 3 on the other side, 2 on both ends. So what's that, 4 and 6? I think it's 10 mechanical interlocks in total. They're using 2 different control systems. They're using the blue locks to isolate the access doors, which require the machine to be stopped in order to do so. They're then using a different color lock, I think they're green locks, to provide them access to the knife area, which is actually just a cleaning area. So they don't need to isolate the whole machine just to do the cleaning process. Important thing here is not really the application, it's the fact that Fortress was engaged to develop this virtual reality environment to teach people through the process of installing these devices, operating these devices, and interacting with these devices. So that manufacturer was able to roll out this video to all of their facilities that have these machines and say, this is the safety upgrade that we're doing to these machines to not only protect the process, but importantly, protect the people that are accessing them. And doing it in virtual reality allows it to be a bit more fun, a bit more engaging, rather than just a simple standalone video. However, as mentioned, the video that will come out will be a video demonstration of how it all works. At that point, before we move on to some some prizes to give away, I can see there's been a few questions in the Q&A function. Do we just want to recap on questions?
Yeah, sure. I can jump in with that. One question that someone's asked, which is hopefully a quick, easy one, is that hygienic guard lock available?
So yes, we're actively engaging customers at this moment. Basically, the way that we tend to release these type of products is that we engage some of our key customers first. We're in that stage at the moment, but it's sort of all starting to open up. And if you are interested, please do get in contact, because it is something we'll be able to talk to you about, whether that's bringing one on site, possibly not during COVID, we might send you one, but you know what I mean. We can start engaging people a little bit more on that.
Awesome. And then another question we've had is, when using 2 keys in your trapped key system, how is the safety key different from auxiliary lockout?
Ooh, Eve, you might be able to.
I was wondering if
you
might pass that on to me. Yeah, so safety keys and interlock blocking, which I think is what you mean by auxiliary lockout. So putting a padlock through the tongue of an actuator or something like that. They're both very similar in kind of the function that they achieve. They're both proactive inhibit functions, both administrative controls, as in the hazard control hierarchy. We'd always recommend trapped key kind of above interlock blocking, especially for the first few people going in. Trapped key just enforces that process, as you cannot remove that key until the right key is in there. And we also have the ability, if you're concerned about whether it's going to be kind of the process is going to be followed correctly, we also have the ability to force that key to be removed before you can open the door. So it's just, whereas obviously if you're putting a padlock on, if someone forgets to do that, there's no way of knowing that someone's forgotten to do that and is actually still inside. And padlocks are quite easy to kind of forget back in your locker, whereas the key that's in the gate lock that has to be removed before you can open the door just forces that process a bit more, which is what we're kind of all about there.
Yeah, that was a far more detailed answer than I was going to go for, to say it forces the process, basically forces the process more. Cool.
Yeah.
There's another question on there regarding the FSMA that I think we can sort of try and talk about. It's not necessarily something we know too much about, but it is something that I think we can try and talk about. Yeah,
so I am not massively familiar with it, but as far as I'm aware, if either of you have any better answers, then jump in. As far as I'm aware, because we're not kind of in the actual food area, we're in that splash area or non-food, it's less relevant. But the fact that we have products that will withstand washdowns, if those enhanced washdown procedures are required, then they'll be able to withstand that. But in terms of kind of contamination, they're not actually in the food area.
So yeah, just to recap on that, the question that came in was regarding what's the impact of the Food Safety Modernisation Act on automation equipment. We view it very much as it's going to affect the actual sort of machines themselves, less around us as an equipment manufacturer. That's really on the perimeter of that environment. For those of you that don't know about it, it's really just a big change to the approach to trying to prevent contamination of food and ensuring increased washdown procedures, etc., are implemented. Yeah, we very much view it. There will be more focus on it. We'll probably get asked for more stuff. We might have to go through some more approval loops down the line, but overall, we probably view that we're getting off a little bit lighter than maybe the actual machine manufacturer themselves that's got to do more considerable changes to what's happening. Cool. Hopefully that wraps up that question. Eva, we've got more questions to look at, because I think there was another one in there regarding safety standards for trapped key.
Yes, I think there was one on whether trapped key can meet different performance levels and how that works. Yeah, there's one of what is the performance level of trapped key.
Do you want to try and answer that one as well?
That might pass straight back on to me again.
Straight back.
And as I kind of mentioned at one point, mechanical systems can also be covered by, can be covered in 13849 and B1126, which is talking about 13849. So performance levels, Fortress Interlocks are, we're pretty sure the only mechanical interlocks in the world that are third-party certified to performance level E. If you're interested in the detail of kind of how that's achieved through TUV, then get in touch, because it's a slightly long answer that I'm not going to bore everyone with right now. But yeah, you can use them in systems up to and including performance level E.
Cool, perfect. So I'm excitedly looking forward towards our tiebreaker question for the audience. Have you got anything else that you want to cover on Q&A before we move on?
I think that was pretty much everything. If there's any more detailed ones, we'll answer them over email afterwards, I think.
Cool. So just to keep us moving on for time, we will put a tiebreaker question on the screen next. We will ask you to answer in the chat function. There is a prize available. The prize that will be available will be a personally engraved Fortress key. We've spoken a lot around Fortress keys today in trap key technology, so the lucky winner will be able to take one away with them. We do have a bit of a backlog at the moment of making those keys, because some of us need to go back into the office and actually process all of those keys through the system. So it might take a little bit while to get out to you. I'll just put that pre-warning ahead of time, but you will have someone reach out, get in contact and basically request what do you want engraved on that key. So without further ado, the tiebreaker question will be going up on the screen. Please answer in the chat function. And the tiebreaker question is, if the overall stopping time is greater than or equal to the access time, interlocking with insert blank here should be used. So please use the chat function to answer that. The other thing that's available as well is that we'll send you an email follow-up, or we can arrange for an email follow-up, is that if you are interested in a US machinery safety standards poster, it's pictured on the right there, and that's basically a US specific machinery safety standards poster talking through some of the ANSI standards and then talking about some key details to remember. They are available and we can send them out to you as requested.
Just while people are filling that in, there's another question coming there, Rob. Are Fortress Interlocks Category 4 claiming fault exclusion from, it actually says 13848, but it should be 13849-2. I'm happy to take that as a question if you'd like me to.
Go on, Malcolm. Let's end on a high and let's end on a very detailed question.
It is an interesting topic. So yes, Fortress Interlocks, we do use fault exclusion on our mechanical components. To 13849 parts 1 and 2, which as standards written currently in use are not particularly well written. 14119 is currently being rewritten and addresses this, allowing what will be called type 5 interlocking devices, trap key to you and me, to meet performance level E, to be used in performance level E category 4 systems with mechanical fault exclusion. Long story, but the answer is yes, and certified by third party.
Cool, perfect. So on that note, we'll reach out afterwards and we'll arrange for that reach out, and we'll thank you very much for coming along today, and we hope you all have a great rest of the day. If you have found this interesting, please feel free to reach out to Fortress or our partner in the Greater Midwest, Palmation.